So let us discuss about another important principle called recursion. So recursion, it's basically a very good example of stack data structure. What is a stack data structure? Stack is basically a kind of a data structure where the informations can be accessed in the form of LIFO, that is last in first out principle. Whatever the recently we have loaded, that only we can access it. And it uses pointers called a top, and also it is using a point called a max stack, isn't it? This is what we call as a stack. And related to the stack, what are the operations we know? We know about push and pop operations. Push and pop operations. Push inserts the data, whereas pop, it deletes the data from the, it's not merely deleting, it's basically, it removes data or retrieves the data from the stack. Okay. Now, so what is called recursion? Recursion, it's basically a normal C function only. So it is a process in which a function calls itself directly or indirectly. The function calls itself. The function calls itself is called recursion. Okay. And the corresponding function is called a recursive function. So we have a normal function. For example, let's say we have a function called add having two arguments, let's say a comma b. Simply I'm writing it here. So inside this function itself, we call this one more time by passing some more two arguments. This is what we call it as a recursive function. You can see that here. Now what will happen when you start the add? Then again it will call the add by passing some argument. Again it will call the this main add. Again it will come here. So it will be continually, it will be in a loop. But we are not going to actually do it in this way. We will take a different path. But this is a basic idea of recursion. The process in which a function calls itself is called a recursion, and the corresponding such function is called recursive function. Yes. If you had looked into previous example, what we have mentioned here, the function gets into an infinite loop, isn't it? But in order to avoid this, what we need to do, we need to have a well-defined recursive function. That's very important. Well-defined recursive functions. What are called well-defined recursive functions? A well-defined recursive function must have a base criteria. Must have a base criteria. What is this base criteria? A base criteria, it is a point from where it can come out of the function. Okay, it can come out of the function. That's called a base criteria. There should be one criteria. After that, it should not execute, it should come out. Okay, that's called a base criteria. And second important detail here is, each time when the function gets executed, it should be brought closer to the base criteria. It should be brought closer to the base criteria. So for an example, let me say I'm starting the function with the number 5. And let me say this is my base criteria. 0 is my base criteria. So what do I have to do? Every time I should try to bring, the simple example I'm giving here. Every time it should try to bring closer to the 3, 2, 1, and it comes to 0. Understand? So like this, every time we should try to bring closer to the base criteria. So such functions are called well-defined recursive functions. So in a recursive function, what we have to do, we must have a base criteria, and also there should be some mechanism to bring it closer to the base criteria. The base criteria may be a variable or maybe a value, whatever may be. That depends on the requirement. Okay. So one good example of a recursive function. As I told you, recursive itself, it is an example of a stack. And a good example of a recursive function is a factorial function, isn't it? So we used to calculate n factorial, 3 factorial, 4 factorial, like that we used to calculate. So an n factorial can be computed by using n into n minus 1 into n minus 2 up to 1. So by multiplying this, we will get our n factorial, isn't it? So this is what the mathematical formula says. And there's another important relationship that we need to note here. To compute a n factorial, if n is equal to 0, if n is equal to 0, that means a 0 factorial, then n factorial will be equal to 1. Okay. Next, if n is greater than 0, if n is greater than 0, then n factorial will be equal to n into n minus 1 factorial. N into n minus 1 factorial. So these two conditions we might have studied in our early classes. So this is the basic formula that we use, but it could be simplified into this way, where n equal to 0 means n factorial, that 0 factorial will be equal to 1. If n is greater than 1, then n factorial will be equal to n into n minus 1 factorial. Okay. Now, the normal factorial function could be function of a variable called fact and n. Okay. So now here, what we do, how do we write it actually? If n is equal to 0, then we'll set fact is equal to 1 and we'll say written from the program. Then again, next what we'll do, we'll set the fact variable to 1 for the further computation. Then we put it into the loop that fact is equal to k into fact, and that will execute it for 1 to n times. Finally, we can write it. So this is a normal approach of writing a factorial function. But what are we discuss now here is a factorial function using recursive functions. Okay. So now here, what is the recursive function? A function which calls itself again and again is called a recursive function. Well-defined recursive functions must have a base criteria, and also every time it should be it must be brought closer to the base criteria. Okay, fine. So how do we write a recursive function? That algorithm we'll discuss. So again, this also will be a function of fact and n. Fact is a variable, n is also a number. Then we know that if n is equal to 0, then set fact is equal to 1. That means fact is a factorial. Okay, fact is equal to 1 and written. Then again, we see that we do that. What do we do here? Call factorial function. Which is the factorial function? The same function. This one only we are calling. But now, instead of passing n value, now you see that here we are trying to pass fact and n minus 1. Fact and n minus 1, it's going to be passed. So n we continue to reduce every time. And every time it's going to call the factorial. Every time it's going to call the factorial. Okay. Then what we do, we find the factorial by multiplying n with the fact, n with the fact variable, fact number. Okay. So by using this, what we can do, we can calculate the factorial of any given number. So this is basically an algorithm that we do. But again and again telling you, it is going to compute with the help of the stacks. Stacks are going to be implicitly used in the recursive function. So when you go for an example, I will discuss with you. So you can see that here, as you know, the stacks are generally used in an application where we postpone our results. Right? For an example, 4 factorial can be computed by using 4 into 3 factorial. 3 factorial can be computed by using 3 into 2 factorial. 2 factorial can be computed by using 2 into 1 factorial. 1 factorial is equal to computed by using 1 into 0 factorial. Okay. but 0 factorial is 1. 0 factorial is 1. So far we not yet calculated. We not yet calculated. So now the process starts from here. The process starts from here. So 1 factorial is equal to 1 into 1. So 4 factorial is computed only after computing the 0 factorial, isn't it? So 0 factorial is equal to 1. Then 1 factorial is equal to 1. 2 factorial is equal to 2. 3 factorial is equal to 6. Then 4 factorial is equal to 24. So from here, again, we bring it here. Okay. We do the necessary computations, but the results will be computed only after finding the 0 factorial. That's a good example of postponing the results. Okay. So let's take this good example here. Okay. So first I will discuss the function, then we will think about the main function. Okay. So now here we have a function called fact. Fact is the function name. Okay. Now, then it is fact. The fact it uses one integer variable called num. One integer variable called num as an argument. It's an argument into the function. Then locally it is using k and it's using a f also as a long data type. Okay, that's good. So now here, first we write a base criteria. See, this is what we call a base criteria. From where? From line number 19 to 22. This is we call it as a base criteria. So every time what we do, we try to bring it into this particular criteria only. So what is that? Num is equal to 0. Num is equal to 0. If num is equal to 0, then factorial is equal to 1. Then factorial is equal to 1. F is equal to 1. Then that also we return. Immediately we return. You can see that multiple return we have used in this function. Before that, I'll come to that term. Okay. So return of F. Okay. That's a base criteria we have set up. Next, what do? We call the fact. We call the fact function. Again, now not passing num. Instead of that, now we are trying to pass what? Num minus 1. Num minus 1. Because our aim is to bring this num closer to the base criteria. What is the base criteria? Num is equal to 0. So when you enter a value here, every time this num should get reduced. So at one point, it should reach 0. At one point, it should reach 0. Then it is having a computation. F is equal to F into num. F is equal to F into num. Then finally, we'll calculate the F value. That will be returned to the main program. Okay. Now, so I'll just illustrate it here first. So what is this function name? This function name is called fact. This function name is called what? Fact. What it does, it calls the function. It for now the fact is called with what number? Let's say fact is called with the number 2. Fact is called with the number 2. Okay. As the fact calls the number 2, what it's supposed to do? It's supposed to do the calculation that fact into 2. F into 2. F into 2. F into 2. This is the calculation it's supposed to do. Okay, so it just makes a note. And next time, what do? Next time, again, we are calling here. Again, we are calling the fact. So now, again, we are calling the fact, but with what number now? Fact of 1. Very good. Fact of 1. Okay, when you call with the fact of 1, isn't it? So what is the computation expected? See, values are not yet computed. It just continue to store the information. F into 1. F into 1. And next time, what will happen? Yes, again we are calling. Again we are calling the function. So again, when you call the function, what will be the detail here? Fact of 0 now you are calling, isn't it? Yes. Fact of 0 is the base criteria. Now we have reached the base criteria. So when fact of 0 is the base criteria, then the factorial will be equal to what? It will be 1. Got it? Factorial is equal to 1. So now here what will happen? So first this will be called this f is equal to 1, 0 factorial. So this result will be given here. This result. This result will be given here. This is how it is done. It's with the help of the first return. This return. Okay. So once it is given here, next what will it's supposed to come out of the program. But before it comes out of the program, what it does, there is when it comes to the execution of this final curly brace, it understands that there are some more internal calls also have been made for which values are not returned. Values are not returned. So first, for a first function call, a fact of 1, the f value will be returned as 1. So now this f value will be returned as 1. That will be computed here and that will be given here to this one. So f is equal to 1 value is returned. Meanwhile, here also the fact is computed. That is what? 1. That is 1. So that is going to be given to this one now, isn't it? Okay. Now coming to this. Here what will happen? So one time it executed. One time this is executed. This is the value supposed to be returned for the main program. For the main program where we have started our computation with the value 2 here. There is one function call for this particular thing. No, for that we are going to return a value now. So as we return a value, now this f is going to be returned here. So 1 into 2, that will be what? That will be 2. So this value f is equal to 2 will be returned to the main program. Will be returned to the main program. Can you see the stack operation here? Stack operation. What is the stack operation? See, this is the top pointer. First we accessed this, then this completed. Next, the top pointer is here. Again we access this. But actually, which one we executed first? First we started our work here. Then we worked out here. But the result was not computed until we get the 0 factorial. After computing the 0 factorial, one by one from the top only, we started doing the work. This is what we call it as a recursive function related to the stack operation. Okay, so this is very, very important for you to understand. Okay, now this is the function. Now there is a main program here. Okay, so main program here. What is the main program? The main program, it's going to use integer variable n and factorial variable long, and it's going to print a screen on the screen factorial of the given number. Then it's going to take the value from the user and it's going to be loaded onto n. Then what is that? This is the main call. This is the first call that we are making. Okay, in our example I told you this is 2. This is 2. So this 2 only will be passed into this function. This 2 only will be passed into this function. And then as it comes, this condition is not satisfied. So it will come here. Then this will become 1. Okay, this entire thing will become 1 because m minus 1, 1. Then again, it will come here. Again, the condition is not satisfied. So it will make it 0. So like this, it will continue to call, but every time we ensure that it reaches the base criteria. Okay, so now then what will happen? Then it will print on the screen. So after executing all this entire complete function, it's going to return the final value. The final value will be on the fact, and the fact is going to be displayed on the screen by using this printf method. Okay, so that's how basically the recursiveness is being happening in this particular factorial function. Now let us execute this program and check. Okay, so what I'm going to do now, I'm not going to run the program just like that, but instead of what I'm going to do, I'm just going to debug this program. Okay, so I set my breakpoint here. So as I do the breakpoint, I've set num is equal to 3. I've set num is equal to 3. Okay, so now let us say, now what factorial we are going to find? We are going to find a 3 factorial. We are going to find a 3 factorial. Yes, it has come here. And this one, I adjusted to this side. and this also I'll adjust it so that you can parallelly we can view the screen. Okay, so now you see that here. So I just get into this. So what happened here, when I give the num is equal to 3, num equal to 3, the 3 is sent into this factorial function, and initially I have given several print statements so that we can see what's happening in the program. So first it makes first gives a function called 2 with n is equal to 3. Next it is changed to the line number 13. It's changed to n is equal to 2. Now that's being passed here, and next it makes n is equal to 1. Then n is equal to 1 is passed into the factorial function. Then what happened now? N is equal to 0. When n equal to 0, you see that here immediately it returns the factorial value 1. Factorial value 1. Okay. Next what happens? So once it is done, first value is returned. This function is returned, but still it's going to continue to return. So when it will return, when it's going to execute this final curly brace, it understands that there were few more function calls that need to be, for that values need to be returned. Okay. Okay. So now let's say you see that it will not return. So function for a first one, for a first call, it's returned 1. For this is for what actually? The fact 1 is for what? Fact 1 is for n equal to 0. This fact 1 is for n is equal to 1. Okay. Now it is supposed to come out, but it will not come out. Instead, what it will do? It will go and compute the next value. Okay. So what is the next value? Next, it has to give 2 factorial. What is the 2 factorial? 2 factorial will be 2. So that value is going to be returned. Next, is it going to continue? Yes. Again, it's going to continue and find what the value of the 3 factorial. What's the fact value of 3 factorial? It's going to compute it here, and that is going to be 6. Okay. So after this, now what it'll do? It'll come out of the program. It will come out of this particular function. When it comes out of the function, where it will go? It will go back to the main program, and it types the result, the final result. The factorial of 3 is 6. Isn't it? So this is the power of recursion, isn't it? So continually the same function executes by calling its same function again and again. That's called a recursive function. Hope you understood. Thank you.